Okay, we are going to take a look at some extra practice graphing our exponential functions. I've got a couple of problems here. We're going to graph them. We're going to identify some key features, just some extra practice graphing these functions. So the first thing I notice is that the base of my exponent is greater than 1. That means that this is exponential growth. Okay. The next thing I want to notice as a process to graphing is the asymptote. The asymptote's the easiest thing to pick out. It's always that number that's at the end. So since I have plus 1 at the end, that means my asymptote is y equals 1. If I didn't see anything here at all, it would be y equals 0. So there's my asymptote, and then I'm going to go ahead and graph this. I'm going to go to where y is 1, and I'm going to extend that line all the way across my graph. Okay. So I've got my asymptote. Check. The next thing I want to do is find my key point. So my key point is going to be based on this number and anything that I'm doing to the exponent. So on the y-axis, I'm going to start at my asymptote. This number tells me to go up 3 spaces. 1, 2, 3. If I were adding or subtracting anything in the exponent, not at the end, remember that's the asymptote, but in the exponent, if I were making any changes there, that would tell me to go left or right. Since I'm not going left or right any, that means my key point is right there, right on the y-axis. So I started at the asymptote on the y-axis and I went up 3 spots because I have a 3 in front there as my initial value. So that means my key point would be this point right here. So 1, 2, 3, 4, 0, 4. Since it's on the y-axis, that is also my y-intercept. Your key point won't always be your y-intercept, but in this case it is. And so now I want 3 total points for my graph. I have 1. Let's find some more. So I'm going to make a table here. I'm going to pick some values for x and plug them in for y. So I already have the point 0, 4. So let's maybe plug in 1 and 2 and see what that is. So if I plug in 1, that means I'm plugging in 1 for x. So this would be 3 times 2 to the first plus 1. Remember to follow order of operations here. So 2 to the first would be 2. So this is 3 times 2 plus 1. Then multiply. So I would get 6 plus 1, and 6 plus 1 is 7. So I have the point 1, 7. So 1, 1, 2, 3, 4, 5, 6, 7. And now if I plug in 2, same idea, I'm plugging in 2 for x. And simplify, follow your order of operations. 2 squared is 4. And then multiply, so I would get 12 plus 1, which is 13. Now this is going to be a little off my graph. It's not so far off that I have no shot at even semi-accurately plotting it. So I'm going to go ahead and plot that point. 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Should be right about there. But if you did plug in an x value and got something so far off your graph that you couldn't even guess where it was at, then my suggestion would be to go back 1. So we had our key point here, and I went 2 points in front of the key point. Remember, you can also pick values back here. So if I wasn't comfortable plotting this, I could also plug in -1 for x. You get to pick whatever x's you want. So this would be 3 times 2 to the -1st plus 1. Remember, when I have a negative exponent, that means that I'm going to flip it. And this would be 2 to the 1st, which is just 1/2. 1 over 2 to the 1st. So then 3 times 1/2 would be 3 over 2 plus 1. 3 over 2 is 1.5. So this would be 2.5. So at -1, we're at 1, 2.5. So I actually got 4 points here, which is just fine. And then I'm going to connect those points with my curve. And I should come back this way some too. Remember, when you're graphing, you should never run into your asymptote. So if you graph a function and you tell me that it's going to look something like this, that's a problem. You should never touch or intersect your asymptote. Okay, let's take a look at another example. For number 2 here, the base for my exponent is less than 1. That means that this is decay. Now, as I want to start graphing, I'm going to look at my asymptote. Remember, I look at the end of my function. Since I'm adding 3, my asymptote would be y equals 3. Since it's positive, y equals positive 3. Now I'm going to graph that. So I'm going to go up to where y is 3 and stretch that all the way across the graph for my asymptote. Now let's find our key point. Now remember, we used that number in front, that initial value, to help with our key point on the first problem. For this problem, I don't see a number in front. That means that it's 1. So this is going to tell me on the y-intercept from my asymptote to go up 1 spot. But this time I've got something in the exponent with x. Since it's -1, that tells me I'm going to go to the right 1 spot. So from my asymptote, I'm going to start on the y-axis. I'm going to go up 1, and then I'm going to go right. And there's my key point. So my key point here would be 1, 1, 2, 3, 4. 1, 4. Now this time my key point is not my y-intercept. That will be one of the points that I find. So for more points on my graph, again, I'm going to make a table. We already have the point 1, 4. I want to find the y-intercept, so that means I want to plug in 0 for x, and then I'm just going to pick one more point. So I'm going to plug in 2. So let's plug these in. So this would be 1/2 to the 0 minus 1 plus 3. My exponent here then would be -1, and that means that we're going to flip this. So 2 plus 3. 2 plus 3 gives me 5. So my y-intercept is 5, and I can go ahead and plot that point. So 1, 2, 3, 4, 5. There we go. If I plug in 2, I would have 1/2 to the 2 minus 1 plus 3. 2 minus 1 is 1. 1/2 to the first power is just 1/2. So 1/2 plus 3 would be 3 1/2. So when x is 2, y is 1, 2, 3 1/2. If you went the other way instead, you could plug in -1 and see what you get for your y value there. But all I asked for were 3 points. So I can go ahead and sketch my curve in here. Let's take a look at just a couple more problems. The base for my exponent here for this third problem is greater than 1. So this is exponential growth. And then my asymptote would be y equals -4. I'm going to go ahead and plot that. 1, 2, 3, 4. And stretch that all the way across my graph. Now let's find our key point. So we're going to use that initial value. And then this time in my exponent, I have x plus 2. That means that we're going to go to the left 2. So starting on the y-axis at my asymptote, I'm going to go up 4. 1, 2, 3, 4, and then left 2. 1, 2. There's my key point, -2, 0. This time my key point is an x-intercept. To find my y-intercept and some more points on my graph, I'm going to make a table. So I already have the point -2, 0. I want the y-intercept. That means I need to plug in 0 for x. And then I have this point. I'm going to find the y-intercept. Let's plug in -1. Again, you can plug in anything that you want. I'm going to try and plug in stuff that's pretty close to my key point. So if we plug in 0 for x, I would have 4 times 3 to the 0 plus 2 minus 4. 0 plus 2 is 2. 3 squared is 9. So I have 4 times 9 minus 4. 4 times 9 is 36. 36 minus 4 is 32. Now, I've identified my y-intercept, but this is going to be really far off of my graph. So I'm probably not going to be able to plot this, right? Because my graph goes to 10. This is going to be off my paper. So I'm going to have to probably plug in another value for x. So let's plug in -1 and see what we get. So if I plug in -1, this would be 4 times 3 to the -1 plus 2 minus 4. -1 plus 2 is 1. 3 to the first is 3. So this would be 4 times 3 minus 4. 4 times 3 is 12. 12 minus 4 is 8. That we can plot. So negative 1 comma 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. And then maybe let's plug in a point this way. Since we're pretty high up, we know our y-intercept is going to be off of our graph. Let's get our third point back this way. So let's try plugging in negative 3. So this would be 4 times 3 to the negative 3 plus 2 minus 4. So my exponent here would be negative 1. That means I would have 4 times 1/3. Negative exponent means I've got to flip this. So 4 times 1/3 would be 4/3, or 1 1/3. And then I'm saying take 1 1/3 and subtract 4. So that would give me negative 2 2/3. So at negative 3, we're at negative 2 2/3 for that point there. So I'm going to sketch in my curve. And there's my function. We'll take a look at one more together. Since the base for my exponent is less than 1, that means I've got decay here. My asymptote is that number at the end. So this would be y equals negative 2. And again, remember, if I didn't see a number there, my asymptote would be 0. So I'm going to go ahead and graph my asymptote. Negative 2, and stretch all the way across my graph. And now I want to find my key point. So we're going to use that initial value. And then since I have x minus 1 as my exponent, this means we're going to move to the right one spot. So on the y-axis, starting at my asymptote, I'm going to go up 8 and then right 1. 1, 2, 3, 4, 5, 6, 7, 8, right 1. If this number were negative, that would tell me to go down 8. But there's my key point. So my key point is at 1, 1, 2, 3, 4, 5, 6, 1, 6. Now we want to find our y-intercept and one other point. So I'm going to make a table so I can plug in some values for x. So I like to record that key point since it's one that we already have. We've got it graphed. I need the y-intercept, so I'm going to plug in x is 0. And then we can plug in, let's try 2. So if I plug in 0 for x, this would be 8 times 1/2 to the 0 minus 1 minus 2. So my exponent would be negative 1, which means I'm going to flip the 1/2. This would be 8 times 2 minus 2. 8 times 2 is 16. 16 minus 2 is 14. So this is again going to be off my graph. Not terribly far off my graph, but off my graph. So there's 10, 11, 12, 13, 14 should be up there. And now let's plug in 2. 8 times 1/2 to the 2 minus 1 minus 2. So 2 minus 1 in the exponent gives me 1. So 1/2 to the first power would just be 1/2. So I have 8 times 1/2 minus 2. Half of 8 would be 4. 4 minus 2 is 2. So I have the point 2, 2 on my graph. 2, 2. And then since that y-intercept is pretty far off my graph, I'm going to plug in one more x value. Let's try plugging in 3. So this would be 8 times 1/2 to the 3 minus 1 minus 2. 3 minus 1, remember order of operations when I simplify, I want to simplify that exponent first. 3 minus 1 is 2. So I've got 1/2 squared. Remember when we square a fraction, we square the top and we square the bottom. So this would be 1/4. So I've got 8 times 1/4 minus 2. So I'm asking for 1/4 of 8, or if you're not comfortable with that, remember I can treat this like fraction multiplication. So I could reduce here, or multiply across the top and the bottom, you would get 8/4, which we know reduces to 2. Either way, you're going to end up with 2 minus 2, which is 0. So I have the point 3, 0 on my graph as well. Now I'm going to connect those points on my curve. And then again, just remember when you're finishing your curve, when you get to that last point that you've graphed, I don't want to draw it as if my graph is going to plunge straight through that asymptote. It needs to curve. It shouldn't hit the asymptote. Okay, and that's a review of graphing exponential functions.